We are doing lesson 5 here, which is graphing, extrapolation, and interpolation. Okay. Originally, this is supposed to be one whole lesson for the entire day, but it ends up it's going to be like a part 1, part 2 situation. So you probably will end up with homework tonight. Sorry. In lesson 5, we're going to talk about I can create a graph using different types of data sets. I can identify trends in data sets or from graphs. I can interpolate and extrapolate from simple data set or graph, and I can interpolate or extrapolate from a complex data set or graph. So those are the things we're going to be focusing on. So let's just talk about graphing. Oh yeah, should probably do that. You're right. You are so very right. I'm just running through it, talking about it, and it's not up there. It's Friday, right? The only thing worse than a Friday is a Monday, yes? Of course you can. Enjoy. All right, so now, why do we graph? We graph because we want to be able to have a visual representation of the data that we collect. So when you go into lab, you're going to have something like, you're going to have a situation where you're going to have an independent variable, and you're going to collect data against the independent variable and see what happens for the dependent variable. And so sometimes when you get that data, it's not going to make a lot of sense until you can actually see it in terms of a graph or a picture, even if it's in a good organized data table. So in this instance, a quality graph is going to always have some of the same things. The quality graph is going to have the independent variable on the x-axis and the dependent variable on the y-axis. And if you sort of forgot, the x-axis is the one that goes like left to right in our class, and the y-axis is the one that goes up in our class. Axis labels will always have the name of the variable and the unit that it was measured in. Axis numbers will have something that we call equal interval spacing, and there's no breaks. So you know how like when you create a graph, sometimes you do that 0 and then the little squiggly thing, and then you start with like a number like 75 million. I hate that. We don't do that in this class. That's a math thing, and we just start with 0 and we make it work. You'll have a title, which will be something like the effect of the independent variable on the dependent variable. So that's what your title is going to always be. And then some other things, you're going to draw a trend line after you plot your data. And your trend line can be straight or curved. So it can be like this, or it could be like this. Okay. It can be those two things. It can go through 0, but it doesn't have to. So sometimes your trend line might do that, right? So it can do that. That's totally allowable. But it doesn't have to go through all the data points. And as a matter of fact, it's not a connect the dots situation at all. So here we go. The next slide is about me telling you how I'm going to be grading graphs that you create in this class. And so graphs are worth big points. So every graph, so for 1 point, you will have a title. For a second point, you will have the independent variable on the x-axis and the dependent variable on the y-axis. For another point, you will have the x-axis labeled with name and unit. And for another point, you will have the y-axis labeled with name and unit. And then for another point, you will have equal interval spacing. On your scale or for your scale. And for yet another point, you will have your plotted data. And then for an even another point, you'll have drawn your trend line. And then for the last and final point, you will have used at least two-thirds of the space given. Okay, so those are the ways that you are going to be assessed when you create a graph, right? So when you add that up, it's like 1, 2, 3, 4, 5, 6, 7, 8. Graphs are big. They're like 8 pointers. So they're kind of a big deal. So every time you do a graph, you have to make sure you do all those things. Okay, and it's not hard because if you kind of get in the habit of doing all those things and you're kind of doing them right and you're doing them well. So, no. 1, 2, 3, 4, 5, 6, 7, 8. That's okay. Dude, I counted wrong 3 times today, so you're fine. You're fine.
Oh, wait, I have the label or like line or whatever. For the second one, I put them as
separate things. Oh, yeah, that happens. That happens. That's all right. I totally missed them on 5th hour, so they're getting an 8-point graph with only 7 points. Anywho, so speaking of graphing, we should probably practice a graph. We're going to do this one together as a team. So here we go. The first thing I usually do when I graph is I try to identify what my independent, my dependent variable are. So I remembered from yesterday that the independent variable is which part of a data table? Which part of a data table has the independent variable in it? The left column, right? So this is my independent variable, and that would mean by default then that this is my dependent variable. So that tells me that I now know what my independent variables are. So I'm going to go ahead and write my title. So I'm going to say the effect of the amount of water on, in this case, plant height. So that's going to be my title. Note is the effect of the independent variable on the dependent variable. And then the next thing that we're going to do is we are going to go ahead and I usually skip ahead to the equal interval spacing because I know that my independent variable is going to go on my x-axis and my dependent variable has to go on my y-axis. But in order to do that, I really want to have my equal interval spacing first. So I'm going to go down a little bit here to talk about how we do that, or at least refresh your memory. Because, I don't know about you, but I'm assuming that you all graphed all summer long, right? You just hung out, like in your backyard, graphing with your people. Yeah. I thought it'd be great if, in the stands tonight at the football game, if like some people like, we're going to make the y-axis, and they're all across the bottom of the stands, and we're going to make the x-axis, and they're going up the stairs, and then we're going to make the points, and I mean, they're playing Shorewood, so that should be an easy win, right? So got to amuse yourselves, right? Am I talking smack? Is that what I'm doing? Oh man. Anyway, so I mean, all right. So anyway, we locate the highest number in the data set. We count the number of spaces given to us for that particular axis, and then we divide the highest number by the number of spaces available, and then we round it up so it's a good, decent number to count by. And then we start at 0 and we label each line and all the fun things that go along with that. That's really, really wordy for like this general generic formula that I usually use, which is biggest value over number of spaces. So the biggest value of my independent variable is 4. So I'm going to put that on top. And then I'm going to count. This is where I really was struggling with counting before. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to put that on the bottom, right? And then I'm going to divide 4 by 10, which is 0.4. And that's like a weird number to count by. Like nobody counts by 0.4s, but some people do count by 0.5s. So I'm gonna do that, okay? And then I'm gonna go ahead and I'm gonna erase my counting marks because that's just messy. And I'm gonna go 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4. Oh my gosh, 4.0, 4.5, and 5.0. And then as long as I'm down there, might as well like identify the labels and things like that. So let's see, this was the amount of water. And I want to make sure I have a label or a unit, and that's going to be in cups, like so. Should probably put a 0 there. Some people get all bent out of shape about that. All right. Then I have to do the same thing for my dependent variable. So again, biggest value divided by number of spaces. So I look at my data set and I see that the biggest value is 8. And then I do some more sweet counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everyone with me. To count, man. So it's 10. 8 divided by 10 is 0.8. And again, nobody counts by 0.8. That's weird. So we're going to round that up to 1. So that means each of my spaces is worth a 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to label it plant height. And I'm going to put a unit there, which is centimeters. And so now I've done a bunch of things. Like I have equal interval spacing. I labeled my x-axis with the independent variable and the unit that was measured in. And I labeled my y-axis with the dependent variable and the unit it was measured in. So now I have to do some plotting of my data. So I'm going to go over 1 and up 2. I'm going to go over 2 and up 4. Go over 3 and up 6. And go over 4 and up 8. And then I'm going to go ahead and I'm going to draw my trend line and try to... That was not decent. Still awful. Much better, I guess. So I drew my trend line. Note that I actually drew my trend line sort of like even past the x or the y intercept. And I do that usually because I just want to see usually where my data is going. Also, I will generally do it if my trend line has a y-intercept that's not at 0. I generally do that. Okay, so that's it. We did a graph. We did all the things. We made a title. We put the independent on the x-axis and the dependent on the y-axis. We have equal interval spacing. We put the labels on both axes with units. We plotted the data. We drew a trend line. We used more than 2/3 of the graph. We got 8 points here. We did it. Yay, it's an 8-pointer. Woo, 8-pointer. All right. Whew. How we doing? All right. Trends in the data. So, what happens is that once you've created this beautiful graph, right, you have to like analyze your data, and it's like you can't just do experiments and not analyze the data. Like that's like just because the experiments are the fun part, you still have to analyze the data. So you have to be able to look at the data itself. You have to look at the independent variable and look at the dependent variable in an effort to identify if there's a relationship present. And if there is a relationship present, you have to be able to articulate that to all. So if it looks like the data is increasing or decreasing as part of the trend, we want to present it that way. So we will be using the format as name of variable 1 increases or decreases, name of variable 2 will increase or decrease. So in an effort to get back into the example from up above, I would write something like, as the amount of water increases, the plant height increases. And I'm just going to add a little bit to it, a little flair, as they say, as well. So that's my relationship between the data. So as we added more water, the plant height increased, and so that was the relationship that was shown there. Now I'd like to point out that like we're at some point we were adding 8 cups of water to this particular plant. Like at some point, if you're adding more water than the plant can handle, you're going to kill the plant, right? You understand that? Like that's what happened to my basil this summer. Remember that month when it did nothing but rain every day in the summer? It like flooded my basil. No, because the plant pot is too big. It's a pretty monster pot. It's about this big. I'm kidding. It's actually really big. It's like a anyway. So, all right. The next thing we need to talk about is this change or is this relationship constant or not constant? If you're looking at the trend line in a graph and the line is pretty straight, we would say that is constant. If you're looking at the line in a graph and it's kind of curvy, that's not constant. If you're looking at a data set and you look at the numbers and the numbers seem to be increasing or decreasing at a rate that's pretty similar, then that's probably constant. If it's not decreasing at a rate that's pretty similar, then it's probably not constant. So those are the things we're going to be looking for and things we're going to be practicing right about now. So here we have a sweet graph. We're gonna like, I don't want to say critique it, but we're going to analyze it, I guess. So on the x-axis, I have my independent variable, which is the amount of coffee Miss E has consumed in cups. And then on the y-axis, we have the dependent variable, which is the rate at which Miss E talks in words per minute. We have a title, the effect of the amount of coffee on the rate at which Miss E talks. The data has been plotted, and there is a trend line that's been drawn. So what is the relationship between the independent variable and the dependent variable? Well, here it looks like the relationship would be something very simple, like as the amount of coffee Miss E has had increases the rate at which Miss E talks increases as well. And again, I'm looking at my trend line, and it looks like the trend is going to be constant. So I would say, yes, this is a constant relationship because the trend line is linear or a straight line. Not too bad. Another example. All right. Here we have a data set. Okay. And I'm going to recall from earlier and a little bit about yesterday is that the independent variable, the IV, is over on the left-hand side, and the dependent variable, the DV, is on the right-hand side of my data table. So that tells me some stuff. I'm going to analyze it and see that the number of weeks since the premiere of this box office blowout is increasing it by one. So it's 1, 2, 3, 4, 5. So it's been like 5 weeks. It's been a month and a week since the movie came out. But it looks like the number of millions of revenue generated from this particular movie has decreased. So our relationship here would be exactly that. So as the number of weeks increases, the money the movie grosses decreases. So then the question is this relationship constant? And I'm going to actually argue that even though the number of weeks appear to be the constant part, the gross in millions is not constant. So I'm going to say not constant. And I'm going to argue that because it's at the rate or kind of the way that the values are dropping. So 47 to 25 is a huge drop. 25 to 11 is a pretty big drop. And then 11 to 7 is kind of a smaller drop. And then 7 to 5 is even a smaller drop. So in my head, I see it going like, whoa, and then kind of like leveling out. Does that make sense? And so that's why I would say it's not constant. So I would say that it's not constant because the rate of money earned is inconsistent. That's pretty much what I would say. All right. Let's see where we're at here. We'd like to talk about interpolating and extrapolating, but I feel like we've done a lot today. All right, so here's the deal. I have to give you some homework for this weekend because I care. Well, I am unlike no other teacher. So your homework is as follows. Get some rest, take care of yourself, and do something for you this weekend. For me, I'm going to sleep in tomorrow. I'm going to get up at 5. Nope. Treat myself. 5:15.
In the morning?
Yeah. Right.